Okay, so I wanted to go over the first few problems with you on the worksheet from today, going over the unit circle. So a reminder that on a unit circle, the hypotenuse, since it is the radius, is equal to 1 every time. And the sine function, because we use the opposite side, which is the vertical side of the right triangles we drew, that would be the y-coordinate, and the opposite over the hypotenuse of 1 would mean that the sine function on the unit circle is the opposite, which is the y-coordinate. And similar deduction for cosine, since the adjacent side is the horizontal or the x-coordinate, and adjacent over 1 would mean that cosine is the x-coordinate. Tangent uses opposite over adjacent, and so that would be our y over our x coordinates from the ordered pair on the unit circle. And to change the degrees that were given in the problem to the radian measure of the angle, we would take the degree and we would multiply that by pi over 180, so that we have the fraction form with the pi symbol in terms of pi for our angle measure. Okay, so starting at 0, the ordered pair for 0 on the unit circle is 1, 0. Now, since the sine is the opposite or the y-coordinate, that means that the sine of the 0 is 0. The cosine is the x-coordinate, so that would mean the cosine of 0 degrees is 1. And then for tangent, since it's opposite over adjacent, that would be 0 over 1. And since 0 is in the numerator, and that's okay to have it up there, the value for tangent of theta is 0. Sorry, the tangent of 0 is 0. Now, when you're multiplying for the radian, you're going to take the 0 degrees and multiply that by pi over 180. And since we're multiplying that, 0 times anything is 0. And one of the things that we do, since 0 appears so much on here and it represents different things, since ratios don't have units on them at all, ever, and this has the degree symbol, we put a pi on the radian value just so that it's in terms of pi and you know it's a radian angle measure. Okay, moving on to 30 degrees. The ordered pair for 30 degrees is square root of 3 over 2 and 1/2. And again, sine is the y-coordinate, so the sine would be 1/2. The cosine is the x-coordinate, so that's square root of 3 over 2. And the tangent, when we talked about the tangent when we had fractions in there, we said that when we do the keep change flip, every time it's going to eliminate the denominators. So remember, for tangent, focus on the numerators only, because the denominators are going to disappear when we do our keep change flip. They would get canceled out. So in this case, that puts 1 over the square root of 3. And we can't leave that in the denominator, so we're going to rationalize. So that leaves me with the square root of 3, and square root of 3 times square root of 3 is square root of 9, so that's a 3 in the denominator. And then 30 pi over 180. Simplify the numbers, so each number is divisible by 30, so that's going to be 1 pi on the top, and 30 goes into 180 6 times, so pi over 6 would be my radian angle. Okay, 45 degrees uses square root of 2 over 2 and square root of 2 over 2 for the ordered pair. So again, y-coordinate, so that's square root of 2 over 2 for sine. And since the x-coordinate is the same, that's also square root of 2 over 2. And then for tangent, you're going to put, again, ignoring the denominators, focus on the numerators. That would be square root of 2 over square root of 2, which when you have the same number divided by itself gives you a value of 1. Okay, degrees. Take the 45 degrees and turning it into a radian. Simplify this. They're both divisible by 45, so this is pi over 4. Okay, next one is 60 degrees. And in that ordered pair, it's switched from 30 because we're looking at the different angle direction of the triangle. So 1/2 for the x, square root of 3 over 2 for the y. So sine is the y, the opposite side, so that's the square root of 3 over 2. Cosine is the x, so that's 1/2. And then your tangent would be opposite over adjacent, so that's square root of 3 over 1. And since anything over 1 is, the 1 is basically imaginary, this just simplifies to square root of 3. And last but not least, the radian degree, or radian angle, 60 degrees times pi over 180. They divide each other by 60, so that gives me pi over 3. Again, you can always check in your calculator, use the division of the two numbers, no pi symbol in the calculator, and then do that fraction program to simplify it down to 1/3 and then put the pi back in. Okay, 90 degrees. 90 has a similar ordered pair from 0. It's going in the opposite direction. We don't go left or right, but we go up the length of the radius, so we go up by 1. And so it's going to be very similar. Sine would be the y value, so that would be 1. Cosine would be the x, so that one is 0. And tangent in this case is going to be 1 over 0. And since the 0 is in the denominator, our silly little remembering tool, no pants. No pants is bad, so that's undefined. Can't have something where there's nothing in the on the bottom. Okay, and then take 90 pi over 180, and 90 and 180 both divisible by 90. That gives us pi over 2. That's 1/2. And so that would be the first 3 trig functions, the first quadrant on the first page of your worksheet. So let's flip over to the second page. And we're going to do the cosecant, the secant, and the cotangent. So again, 0 has the ordered pair of 1, 0. 30 is square root of 3 over 2, 1/2. 45 is square root of 2 over 2, square root of 2 over 2. 60 is 1/2 square root of 3 over 2. And 90 is 0, 1. Okay. Now, going back to the idea, cosecant is the reciprocal of sine. So if it's the reciprocal of sine, that means that we flip the ratio for sine and to get the ratio for cosecant. Same thing for secant. We're going to have the reciprocal of the cosine, so we're going to flip the cosine ratio to find the secant ratio. And cotangent is the reciprocal of tangent, so again you can flip the tangent ratio. Okay, so since sine on this one was 0, that would be 0 over 1. So to do the reciprocal of this, you would have 1 over 0, or undefined. So the cosecant is undefined at 0 when sine was 0 there. And cosine is 1, and as a whole number, 1 over 1. So 1 over 1 reciprocals to just 1. Tangent is just the same as sine on this case. It's 0 over 1. So doing the reciprocal again is going to give us an undefined value. And go ahead and write the angle here that you got in the last one. just for repetition purposes, so you can remember that 0 degrees and 0 pi are the same thing. Okay, here we're going to do the reciprocal. For sine, we have 1/2, and if we flip that upside down, that becomes 2 over 1, and that's going to give us a value of just 2 for our cosecant. Okay, so we're doing the reciprocals of the original values that were in the ordered pair. Okay, cosine is square root of 3 over 2, so reciprocal would be 2 over the square root of 3, which we need to rationalize. So that's going to give me 2 radical 3, and again, multiplying these together is square root of 9, so that simplifies down to a 3 in the denominator. Now tangent here, we had 1 over the square root of 3, so the reciprocal of that would be square root of 3 over 1. Now for cotangent, a lot of times I will go back to the ordered pair because I had to rationalize in my tangent function, so it might be easier to go back and look at the actual ordered pair. Now if you go back to the tangent function, being square root of 3 over 3 is the tangent of 30, then you can look at this and say, okay, well that means the reciprocal is 3 over the square root of 3. So I'm going to have to rationalize again, and that gives me 3 radical 3 over 3. So these 3's on the outside can cancel. Treat it similar to what we do when we do the pi ratio. We simplify the numbers on the outside, leaving the radical alone. So this simplifies to just square root of 3. And you can see that putting the adjacent over the opposite, that's square root of 3 over 1. Okay, again, writing down our radian value for 30, pi over 6. Okay, 45 degrees. Cosecant is the reciprocal of sine, so we're going to flip this opposite side here to 2 over radical 2, rationalizing, and that would give me 2 radical 2 over 2, because when you multiply these, that's square root of 4, so that becomes 2. And again, similar to what we did over here with the 3's, these 2's are going to cancel, so the reciprocal of that would just be a 2. Since the cosine is the same ratio as the sine at 45 degrees, that means the secant will be the same ratio as cosecant. So this is going to also be a square root of 2. Cotangent is going to be the reciprocal of our tangent, and tangent was 1 in this case, and we know from looking back at this value that the reciprocal for 1 is just 1. And then rewrite the radian value, pi over 4. Okay, we've already done the reciprocal simplification for these numbers because they were the same numbers in the 30, but they're in the opposite order. So we know that reciprocal of square root of 3 over 2 is going to be 2 over the square root of 3, and since we already did the calculations up here for 30 degrees, we can go ahead and write 2 radical 3 over 3. And the reciprocal for the 1/2 is just 2. Okay, and then here, tangent for this one, the tangent of 60 degrees is just radical 3. So that means the reciprocal of that is 1 over radical 3, which gives me square root of 3 over 3, like we did on the first page when we simplified it down. So you'll notice that these numbers on 30 and 60, they tend to switch places with the previous values. So the sine and the secant end up having, the cosecant and the secant end up having the same value but on opposite angles. Okay, and then this is pi over 3. Okay, 90 degrees, the reciprocal of 1 for the cosecant is going to be 1. We've done this a couple of times. And again, 0 over 1 for our cosine value, that would be 0, and we flip that over so that becomes 1 over 0, and that becomes the undefined value. And then cotangent, since tangent at 90 degrees was undefined, that meant that it was 1 over 0. So in this case, cotangent is going to be 0 over 1, or 0 for the ratio. And the angle value for this would be 90 times pi over 180, and that's going to give us pi over 2, as we said before on the previous page. So that is your first quadrant done. The other quadrants, you want to pay attention to the pluses and minuses on your ordered pairs so that you have your correct sign on the value. Make sure that you are using both the positive and the negatives. If there's two of them or just one of them, make sure you're using them correctly. And don't forget to pay attention to the patterns that you see here, okay? And this is due on Sunday night into your Google Classroom.